Linear regression. These are the steps in the calculator. So you definitely need to make sure you have downloaded the Wabbit emulator onto your laptop or Calculate 84 onto your iPhone. So what I have given you here is we have an example that is directly in your OneNote. And over here we have the linear regression steps. Okay, so these are the steps you need in order to find the linear regression in the calculator. Many of you remember how to do the stat edit, and a lot of you have asked me about it, so that shouldn't be too much of an issue, but I'm going to go through the steps with you, and it tells you even what buttons to press, so you definitely want to use this as a reference. We're going to do the example over here on the right, okay? So the first thing I always ask students to do, and you'll notice over here, is clear your calculator. First thing you always need to do is clear your calculator. It is key to get that calculator cleared. So you're going to do second plus 7, 1, 2, and clear your calculator. Okay. Then the step tells us to hit stat 1 right here. Stat 1 to edit the lists, okay? So we're going to come over here and we're going to hit stat 1 and we're going to edit the list and put both of these lists in. Just as a reminder, this is X, this is Y, this is your L1, and this is your L2, okay? So I'm going to come over here and I'm going to enter it into my graphing calculator. This is slow and this is tedious, and I do understand that. So take your time right now while I'm entering it and you enter it as well. Be careful and make sure you're entering each one very carefully. You need to enter every single number for accuracy. I'm using the arrows to scroll up, and I'm going now to enter my Y values or my calories. Take your time. And something really important to note is you want to make sure over here that you have the same number of items in each list. That's one of the number 1 mistakes, okay? So the first question on our example over here is to find the line of best fit. So we are going to start working through these steps over here. Okay. So the next step is to turn on the stat plot. So second, Y equals 1, enter. And notice that it's now blinking it on. That's what you want to do. You want to turn it on. So now it tells us we're going to hit zoom 9 to get this screen. So I'll bring my calculator back up. So I'm going to hit zoom, which is the middle button right up here, 9, and it's off. Okay, if y'all notice, this is not matching this screen. So I have to go back to my list and find out where I messed up. So clearly, right down here, I see that I have a 55 instead of a 550. So I'm going to go fix that, and it happens, and that's okay. Now, I'm going to hit zoom 9 again. Fingers crossed that it matches. Okay, so it matches the screen over there. All right, so now I'm going to turn the diagnostic on. What happens when I turn the diagnostic on is it's going to show us the correlation coefficient. The correlation coefficient is how accurate is your line. Don't worry about it. Just sit here and follow each button step to get to what you need to get to. This is if you need to find the correlation coefficient. Watch on all of these, you're going to need to. And this is cumbersome. You need to scroll down to the diagnostic on. It takes a while. There we are, diagnostic on, okay? Once you get to diagnostic on, and notice I have it over here, you're going to hit enter, enter. and this has turned the diagnostic on. So I'm going to go over here and I'm going to be sure I circle this so y'all see that y'all want to turn the diagnostic on, that you're scrolling down to the diagnostic. All right. So then I'm going to scroll, and here's the big stuff. Here's all the important stuff on it, okay? These are the steps. Step 5 is key. Step 5 is the most important part. So now we're going to go to stat. Notice I have all the button presses right here. We're going to hit stat, side arrow, and we're going to go to 4 because that's the linear regression. That is what we want to find. And it takes us to this screen. On this screen, okay, we want to scroll down to the store regression equation right here. So we're going to scroll down until it's blinking at store regression equation. What we are doing right here is telling it to put it into y equals for us so we can look at the line. That's what we're telling it to do right now. So you are then going to hit vars, side arrow, 1 for function, 1 for the first y value, and then you're going to hit enter, enter to calculate it. If you miss this step, you can go type in your equation. Here is where it's key. Do not enter past this screen. If you enter past this screen without writing it down, you have to do all the stuff we just did again on step 5. So you want to make sure you get this equation written down right here. So I am going to come over here and I'm going to point out to y'all that this is the screen right here to give me the equation. So this is an exact picture of what you're seeing on your calculator. And what I'm going to do is I'm going to point out to you guys where we're getting the information from. So if you look over here, A is my M value. Here is the A value. And you want to do 2 numbers past the decimal. And you're going to plug that in for your M value in the equation. Okay, then we're going to look at our y-intercept, which is our b value. And here is my b value. It happens to be a positive. I don't know what my pen is doing over here. Okay, and that is my b value of my equation right there. I don't know exactly what this pen is trying to do right now. There you go. And now I can fill in my equation. I also need to write down my correlation coefficient, my R value. This is telling me how close to 100% accurate is this line right there. Okay, how close to 1 is this line? It's pretty darn accurate. It's pretty darn close. Okay, so I'm going to come up here and I'm going to answer these questions in just a second that are on our paper over here. Well, let's go ahead and ask it now. Let's go ahead and answer it. So the equation that we got was y equals 11.73x plus, lost my mouse for a second, plus 193.85. So go 2 numbers past the decimal is the best way to do it. Okay, so there is my equation. The next thing asks, what does the y-intercept or the b mean in this equation? All right, so then we're getting on to a little bit of interpretation of it, okay? So what does that b value mean? Okay, so let's look again at what we're talking about. We're talking about total fat and calories, and we're talking about where it crosses the y-axis. And what happens to be there is that's where x is 0 at. So our fat is 0, which means, okay, that the y-intercept would be the number of calories. Okay, so calories when 0 fat, okay? Or it's where it crosses the y-axis when x is 0. Okay, so that one can kind of vary just a little bit. It means there's 193.85 calories just with 0 grams of fat. Stuff can't have calories without fat, guys. Okay, look at sodas and stuff like that. All right, then it wants to know, what does the slope mean? What does the slope of the graph mean on this one? The slope is our m value, and it's 11.73. That means that it goes up 11.73 calories for every gram of fat. Now, one of the things I want to point out to you guys, and I really, really want to point out to you guys, is that this is a line of best fit. It is a line of best fit. It is not a perfect one. It is the line that goes in between all the data perfectly, so it is an interpretation, okay? So then we're going to go down here, and it wants to know, what is the correlation coefficient? So here's where we're going to answer the rest of these questions. The correlation coefficient down here was 0.974. And it asks us, how accurate is your line of best fit based on the correlation coefficient? Our line of best fit is pretty accurate. It's basically, how close is it to 1? So it's pretty accurate, and it is a strong positive. What would make it weak is if it was like a 0.85 or a 0.72, okay? Then we get to what we're going to do with this data. Okay, we need to interpret some information. We need to interpret what the calories will be with 42 grams of fat. So we're going to go back over here to our steps, and we can graph it by hitting graph. And then we're going to interpret information. So right down here are your steps to interpret information. And what it says is, to get a value for a given variable, you're going to use the table and scroll to the desired value. It's the easiest way to do it. But you'll notice the bold down here. If the value is too high to scroll, i.e. where x equals 300, we ain't got time for that. We ain't got no time for that to scroll down to 300. Then you're going to calculate it using the equation. So you would just plug it into the equation. So I'm going to show you how to do both things, okay? So what I'm going to do now is I'm going to split my screen. All right? And I'm going to put my calculator over here on the left. Put my calculator right over here on the left so that we can finish the notes over here on the right. Okay. So what it wants us to do now is, what will be the calories if the items has 42 grams of fat? So I'm going to use the table. So to get to the table, we hit second graph. All right. And 42 grams of fat. Was grams of fat your X or your Y? Go ahead and take a second to scroll up and remind me, was it your X or your Y? Let's go ahead and scroll up ourselves. It was our X, was grams of fat. So we are looking for, on this problem, we are looking for where X equals 42. We're looking for where X equals 42. So literally scroll down to where X equals 42. I can scroll to 42 pretty quick. It's not going to take too long. Okay. And where X equals 42, there are 686.57 grams of fat. Okay. So that's how many grams of fat. It's a lot of fat. Okay. Now, the other way you can do it is by plugging it into the equation. And I do want to show you guys how to do that as well, because I do think it's important that we note the different methods we could use. So, or you can plug it into the equation where X equals 42. So our equation was Y equals 11.73 times 42. I'm plugging it in for X, plus 193.85. And you just plug that into the calculator and it'll give you the same thing. Okay? So then we're going to go over here and we're going to solve G. And G is a big one. Okay? Okay. So when I look at G, G says find the minimum number of grams of fat. So you're looking for X when Y equals 2,400. Guys, I ain't got no time for that. I'm not scrolling down to 2,400. Okay? I might have for note purposes, but I ain't doing it again. So what I would do for here is I would plug this into the equation for Y. So Y is the first number, 2,400. Y equals 11.73X plus 193.85. And these are not always going to be pretty numbers because they're lines of best fit. They're not necessarily exact. So what we want to do now is we want to solve for x because we're looking for what is x, how many grams of fat, when y equals 2,400. Okay, so I'm going to subtract the 193.85, and yes, this is an ugly problem, but you ain't got to do a lot of them, guys. You don't have to, okay? So that leaves us with 2206.15 equals 11.73x, and you guys solved a lot of equations. Now, I have 11.73x. When the numbers and the letters are right next to each other, okay, what are they doing? They're multiplying. So to get rid of multiply, you're going to divide. So x equals, and that would be 188.08 grams of fat. 188.08 grams of fat. Okay? Now, if you solved it by scrolling down the table, you would have found out that it was somewhere between 188 and 189, and I would have accepted that as an answer as well. Okay?